In today's lesson, we'll be learning how to calculate the slope of a line tangent to a curve at a given point. The example that we have asks us to do just that for the curve f of x equals x squared minus x minus 6, and we'll want to find the slope at x equals negative 3. To do that, we're going to begin by reviewing the definition of a derivative. Derivative is tied to the slope of a tangent line. So let's look at the derivative's formula. Now just recall that this formula for the derivative came from the slope of a secant line for 2 points that are h units apart. This is the change in the y's, this is the change in the x. And because we are talking about a tangent line, we want our h value, the distance between those 2 points, to be infinitely close to 0. So we're going to apply this definition of a derivative, which is the slope of a tangent line, to the curve that we are interested in. So what we're going to do is go ahead and calculate this derivative. So the derivative f prime of x is equal to the limit as h approaches 0, or is infinitely close to 0, of f of x plus h, which I'm going to get from this function here. So I'll replace that with x plus h, the quantity squared, minus, replace the x also with an x plus h, minus 6. Subtract from that the function itself, f of x, which is x squared, minus x, minus 6, and that whole quantity is going to get divided by h. Now what we're going to try to do is we're going to try to expand some things and hopefully have some things cancel out. So in our next statement we'll write the limit as h approaches 0 of, using the distributive property for x plus h, we would get x squared plus an inside-outside terms of xh, which would result in 2 xh's, a last of h squared. Distributing the minus here, we have a minus x, minus h, minus 6, and then distributing the final subtraction would result in a negative x squared plus x plus 6. And again, that whole quantity gets divided by h. In our next step, we're going to hope that some of the things that we just expanded are going to simplify, so to cancel. And we can see that that's going to happen. We have here an x squared and a negative x squared. Those are going to cancel each other out. They add to nothing. We have a negative x and a positive x. We have a negative 6 and a positive 6. So all of those terms cancel each other out. What remains in the numerator is a 2xh, an h squared, and a negative h. And in the denominator we have an h as well. So the next thing we're going to do is we're going to use the distributive property of division. This h in the denominator applies to each of those terms. So I'm going to rewrite this as 2xh over h plus h squared over h minus h over h. And again, we're looking for some things to cancel, and we can see that some things are going to cancel. Each of these terms has an h in the numerator and an h in the denominator. So I'm going to go ahead and cancel this h with this h. That'll leave me with a 1. And one of the h's in the top and the h in the denominator for that second term, and then both of these h's are going to cancel as well. So what remains is the limit as h approaches 0 of 2x plus h minus 1. That's h divided by h. So what we want to see is what happens for very large values of, for very small values of h in this expression. So for very small values of h approaches 0, gets infinitely close to 0. This term right here gets infinitely close to 0 as well. And what we have remaining is called the derivative. F prime of x is 2x minus 1. And remember that this is the thing that's going to give us the slope of a tangent line. We just have to find the slope on this curve. Remember, the slope changes depending on where you are. We today are interested in what happens at x equals negative 3, as is given in the original problem. The slope then would be 2 times negative 3 minus 1, which is negative 7. So our final answer for this problem, a slope of negative 7.